my name is Mason Alb. My river that I'm studying is located in southern Ontario. Currently standing right next to the exit of the Rideau River and as it drains into the Ottawa River to my right.
The Rideau River, better known as the Rideau Canal, starts in the upper Rideau Lake area, flows through the Great Rideau Lake into the lower Rideau Lake, until it eventually flows north and drains into the Ottawa River. The Ottawa River then drains into the St. Lawrence, which reaches the Atlantic Ocean on the far east coast. Due to the low gradient of the area and the snake-like pattern that the river follows, I would identify it as a meandering river. However, due to the reinforced levees and filled-in point bars, it lacks many attributes of a naturally flowing river. Since the river's been running along the same path for so long, there are some points where it creates a deep valley and seems almost like an incised river. Ottawa and the surrounding region has a warm, humid continental climate. It has very cold, dry winters and very hot, humid summers. The Köppen-Geiger classification for this area is DFB. Ottawa has steady precipitation levels year-round. The summer and fall months see lots of rainfall, and the winter months see heavy snowfall. The region sees a large variation in temperature, with hot summer months reaching into the high 20s and cold winter months reaching far into the negative double digits. The Rideau Canal sees an average discharge rate of 20 meters cubed per second in the summer, fall, and winter months. However, as the temperature increases from winter to summer months, the spring sees a sharp increase in discharge rates due to snow and ice melting. The highest discharge rates occur in April, when the Rideau Canal reaches discharge rates above 90 meters cubed per second. The Rideau Canal runs along a shallow gradient, moving from its peak height at 126 meters above sea level in the upper Rideau Lake to 42 meters above sea level at the Ottawa River. The river runs its course along a flat area with little to no hills around it. The flat topography allows for the river to meander back and forth as it moves north. I began my study at the hydro dam at the mouth of the Rideau Canal, where it meets the Ottawa River. Then I headed south towards Hog's Back Park, where it meets a large reservoir south of Ottawa. Due to the dense residential and commercial areas around the river in Ottawa, there's lots of reinforcements and artificial levees put in place to prevent the river from meandering and eroding the sides of the river.
Here's a good example of levees installed on the river. The river's coming in far this way, so they put in these levees to prevent it from meandering any further and to make sure it directs right into the hydro dam that goes into the Ottawa River.
Just below the reservoir is where we'll find a nick point that shows large waterfalls and rapids. Here we can find large sections of sandstone and limestone that were uplifted and broken apart long ago. This break resulted in a large change in altitude, which leads to these falls being created. Below the falls, we find a very turbulent section of the river where the water is moving around very quickly. This leads to the creation of eddies where the water is moving against the current and upstream. These eddies occur because the water is moving very quickly past an obstacle, creating a sort of vacuum right behind it. This means water outside of the current must rush in to fill the space before rejoining the main current and moving further downstream. The Rideau Canal has a generally shallow gradient. However, in some spaces, there are large changes in altitude due to breaking of bedrock. The sections of the river that we find on shallower gradients exhibit meandering attributes, where the river flows back and forth in a side-to-side motion. This leads to the construction of levees to prevent the bank from being eroded and protecting the nearby houses and buildings. These sections of the river have large volumes of water moving relatively slow. These sections are split up by sudden changes in altitude that lead to waterfalls and rapids. In these areas, the current moves much faster and in a much more haphazard way, creating turbulent areas with whirlpool and eddies. The waterfalls and eddies occur year-round, but are much more predominant in seasons of high discharge rates, like in the spring. While examining the Rideau Canal, my knowledge of the many functions of rivers allowed me to understand the specific mechanisms and things that go on within them. These characteristics allowed me to understand why there are levees in certain areas and why you can find waterfalls and eddies in others. These three features, alongside many others, gave me a profound understanding of the river. Learning about these mechanisms in class and then seeing them in action was truly quite fun and amusing. It gave me a great appreciation for rivers and their many complexities. This project has allowed me to observe rivers through a new lens, where I can truly understand how they function. This is something I will have for the rest of my life, and for that I am grateful. Thank you.